we are having these vectors and we are having different properties which are related with the vector, and that we need to know as we are having this basically two things in this vector. One is magnitude and other is direction, and we say we want to find the magnitude and direction of the vector. How we can find that one? So it's not difficult, it's easy one. Again, I just take the example. We have two dimensions. We're having here my y-axis, here my x-axis, here my y-axis, and y-axis, and I have this vector. This my vector is vector A, and component vectors A are A1 and A2. These are my component. This A1 means this length along x-axis, and A2 means length along y-axis. So if I take as a right angle triangle and I want to find this length, so length of A, side A, and that's, we say this is equal to, by using Pythagoras, this is equal to A1 square plus A2 square. Actually, this is the length of the vector A. We say it's the magnitude of vector. We say it has a magnitude of vector A. We say this is equal to A1 square plus A2 square. So that's the idea. That's number one, how we find the magnitude. So we can extend this one for 3 dimension, just dimensions for 2 dimension, and then we extend this one for 3 dimension. Now we say we want to find the direction. Now direction, we say we can find here a vector we call the unit vector. We denote it by U. We say this give me the direction. When we say unit vector means its length must be equal to 1. So number 2, for the direction is given by unit vector. And as I said, the unit vector is what? It's the direction 1. And we denote this one by vector U. So my vector U, if I divide A by the magnitude of vector A, I denote this magnitude of vector A by this notation. This is here is this denotes the magnitude of vector A. So if I divide any vector by its magnitude, then obviously we say the length of the vector is equal to 1, and that's the unit vector, and that gives me the direction of the vector which I want to find. So we can just have the small example. Here we extend this example to 3 dimensions, and we can say we're given here the vector A, and we want to find the magnitude and the direction of the vector A. So here I can have the first I write the basic formula for that one. We have vector A is having in 3 dimensions, we are having A1, A2, and A3. I want to find the magnitude of vector A. Magnitude of vector A, we denote it by double bars, as I mentioned, and this is equal to A1 square plus A2 square plus A3 square. Number 1. Number 2, we want to find the direction. So as I defined before, my direction of vector A is a unit vector, U. And we denote U is what? We are having A or magnitude of vector A. This is my direction of vector A. So this is the same formula. We can extend it for, this was for 2 dimensions, and here we extend it for the 3 dimensions. So same formula we can apply, and we can find the magnitude of vector. So I can just give an example. It's very simple, as we are having the very simple formulas. So we don't forget it, how we find the vector PQ, and then we can just apply it, and we can just make an example so that we can use this both of the ideas. Our example is find vector PQ where we have a point P, the point 0, 3, 7, and point Q is 1, 5, and 8. So also find magnitude and direction of vector PQ. So we have to find vector PQ, and then we have to find the magnitude and direction of vector PQ. We just do it here. We are having here, we use this formula, solution of this one. We are coming from here to this direction. What is our PQ? X2 minus X1. This is my X2, Y2, Z2, and this is here is 1 minus 0, Y2 minus Y1, 5 minus 3, Z2 minus YZ1, 8 minus 7. What we get here? We get here 1, 2, and 1. So it's my vector. Then we want to find this number 1. Number 2, we want to find magnitude. Magnitude is equal to the vector PQ. As I mentioned, we write the magnitude like this one. What is this magnitude? Magnitude is A1 square, A2 square, X component, Y component, Z component. A1 square, 1 square. That's A2 square is 2 square. A3 square is 1 square. We're having this equal to 1 plus 4 plus 1 under the root. And then just calculate this one. This is 6 under the root. That's my magnitude. Number 3, I want to find the direction. So what's my direction? My direction is my unit vector u. What's my u? My u is my vector a, or my way a is PQ, or magnitude of PQ. So I am having here, this my PQ is equal to 1, 2, and this here is 1, 2, and 1 over root of 6. Or we can write this one as, this is always better to write this scalar. We can write like this one. This is 1, 2, and 1. So this will be a unit vector. If you calculate the magnitude of this one, magnitude of this one will be equal to 1. So it's very easy, not at all difficult. Just you have to, anything you want to learn, just you read it carefully and revise it if you are not clear, and you can learn it. And then the second thing, which I always say, make practice. It's a mathematics. It's not the art subject. For mathematics you want to learn, you have to do the exercises. And as I mentioned, it's always I'm putting my notes in the description, and you can just copy my notes from there. You can just have this soft copy. You can print out. There are also exercises given in that one, and you can learn more. Yeah, do the practice. And then, as I mentioned, if you want to continue and you want to find the notification of this one, then subscribe the channel and also press the bell icon so that get the notification. So this is the idea that how we can write our vector and identify our scalar. Scalar is having only magnitude, and the vector is having the magnitude also direction.